Okay, so light gates have a beam of light going from one end to another. So this can be visible light or maybe infrared. And when an object intercepts that beam, the data logger can time how long it was intercepted for. So when the beam is cut like this, it will be timing how long it's being cut for. And when the beam is reformed, it can stop timing. Okay, so light gates can be used to measure the speed of an object. So in this case, I've got a card of length L. So let's say that's around 5 centimeters. So I would use a ruler to measure the length before I start this practical. I let it pass through this light gate at some speed. Okay, and then the timer, the data log gives me how long it took for it to pass through that light gate. So it took 40 milliseconds for that 5 centimeter card to pass through the light gate. Then I can just simply use the velocity equals distance over time, or in this case length of the card, which is 5 centimeters, so I've turned that into meters there, divided by 40 milliseconds. That gives me a speed of 1.3 meters per second. Okay, another way to find the speed is to use two light gates like this connected to the data logger. In this case, I've got an air track which has no friction, and there's a glider sitting on it, and if I give that glider a push, it will travel at a constant speed between those two light gates, like this. And I can set the data logger to give me the time it takes for the glider to travel from one light gate to another light gate. So let's say 0.80 seconds. So now I can use this to find the speed using speed equals distance over time. So the distance that's covered over that time is the distance between from the center of one light gate to the center of the other light gate, S. So let's say 1 meter in this case. So the distance traveled 1 meter divided by the time, that gives me a speed of 1.3 meters per second. Okay, so light gates can also be used to measure the acceleration. So in this case, I'm going to try to find the acceleration due to gravity. I have this dowel here, which is 4 centimeters long, and I would measure that using a ruler. I'm going to let it accelerate between those two light gates like so. Okay, and the light gates can be, and the data logger can be set to give me the time it took for the dowel to pass through each light gate. So the first light gate, let's say it took 40 milliseconds to pass through that. So if I take the length of the dowel, which is 4 centimeters, divided by the time it took, it gives me the speed, 1 meters per second. Now through the second light gate, we expect it to go faster, so there's shorter time through the second light gate. So it'll only take 10 milliseconds. So if I do again the length of the dowel divided by the time, that gives me a speed of 4 meters per second. Now to find the acceleration between those 2 points, one of the things I could do is measure the distance between the first light gate and the second light gate. So let's say 0.80 meters. And then I can use a SUVAT, v squared equals u squared plus os, put the numbers in to get the acceleration, and in this case I'm getting around 9.4 meters per second squared. So maybe because there was a bit of air resistance, or maybe because there's some friction between the dowel and the transparent tube, that the acceleration is in 9.81. Okay, some data loggers have a graph instead of time, giving you time values. So in this example, I'm going to let this cart roll between those two light gates. It's going to accelerate down through those light gates, and you get a graph on the data logger that looks like this. Okay, so here I can use this data to find the acceleration. So one of the first things I would do is measure the length of the card before I even start the practical. And if I want to find the time between T1 and T2, that's when it went through the first light gate. So when the beam was being intercepted in the first light gate. So I can find the initial speed by doing the length of the card divided by the difference between T2 minus T1, because that's the time it took to travel through light gate 1. If I do this again for light gate the T4 and T3, I'll get the final velocity at the light gate 2. Okay, and then finally, if I want to find the time it took to travel between those two light gates, I can measure the middle point between T1 and T2, which is add them together and divide it by 2. Basically, I find the average, and repeat that again for T3 and T4. So I've got the midpoint between those 2 points. So now the time taken to travel between those two is the difference in those two average times. Okay, so that gives me time, and I'm going to use that in my SUVAT. So acceleration equals change in velocity divided by the time, and that can give me the acceleration there. Okay, sometimes some data loggers have some sophisticated function where you can actually use a card that looks a bit like this. So where you need to measure these distances, the distance of each of those stripes and the distance between them as well. And if you put that into the data logger, it can just measure the acceleration straight away. So for example, when I release this car, the mass is going to accelerate it through the light gate like that. And the data logger can just give me the acceleration straight away if I give it those numbers.